Good morning. This is Michael Herzog from nexB, and I'm here today to talk to you about securing open source supply chains using free and open source tools. Basically, to discuss this topic, we need to review what software bill of materials are and what software composition analysis is, because those are the building blocks for software supply chain security. Throughout the presentation, we'll be talking about how to use free and open source tools. The key benefits are at a pretty high level. One is avoiding vendor lock-in in general and avoiding the costs and inflexibility associated with that. Equally important is that we need to enable upstream projects to use SCA and to build SBOMS for better supply chain security. Everything in free and open source software begins upstream. And those projects rarely have the resources in terms of money or people to do this work. And particularly if the tools are proprietary, they're pretty much locked out of the process. It just becomes too difficult to do. So we'll start with a review of SBOMs and software composition analysis, and then give many examples of how you can use free and open source tools to manage software supply chain risk. The primary focus of this discussion is free and open source software, but it is important to remember that proprietary software is at least as vulnerable to cybersecurity problems and licensing problems as open source software. So most of the logic and the discussion here also apply to proprietary software. The big difference is that information about proprietary software is not available in public in most cases. So that's actually a harder problem to solve. A little bit of background on nexB. We've been in this business for 16, 17 years. We are experts in software composition analysis and acknowledged by the open source community and work with many top companies. And we've built a suite of best-in-class software composition analysis tools, which is what we'll discuss in some detail today. Throughout our work, our mission has been FOSS for FOSS, again, free and open source software tools and systems for the FOSS ecosystem. This is just sort of symmetrical. There's a certain irony, or strong irony, where many proprietary companies and now a lot of venture-funded startups are jumping into this market, charging very high fees and not really giving back to the community. So we're focused on the community and helping everybody in general. Some examples of key things we developed is ScanCode, which is one of our products, our projects. It is also the leading scanning tool today. Our founder, KP and Philippe Omberdon, was the original creator of something called package URL, which has become the standard for identifying packages in general, not just for open source. And Philippe and I were founders of SPDX and Clearly Defined quite some time ago. So starting very simply, you've probably heard this a lot. A lot of people talk about this. Software bill of materials is a list of software components. What people don't talk about enough is that the concepts here are all borrowed from discrete manufacturing, such as manufacturing computers and phones. And there's a huge body of knowledge from that domain that's not really well leveraged yet in the software domain. We're trying to work on that. It's not hard to understand a hierarchy, a graph, a list, but there is a huge problem area, which is defining what is a software component. And we just have to live with the fact that there is no such standard. The closest thing is the Perl, which we'll talk about more. But people use the word component, package, software, code, all different ways, and you just have to be prepared to deal with that. At a high level, a component might be a file, could be source, binary, it could be a set of files or package of files if it's a package. It could be an archive of some sort, or with metadata, with interesting information about the license and the origin, or it might be without any metadata, such as a zip file. So it's just it is confusing, but you just need to sort of put one step in front of another and start working on it. Also, there are many, I would not say infinite, but there's a wide range of SBOM use cases, as with manufacturing. It's essentially a mechanism to communicate information between organizations, and some of the most common use cases are an SBOM for packaged software. Typically, that's not in a physical package anymore; it's a download. But when you download an app for a mobile device or a piece of software on your computer, having an SBOM with the software is where we're headed. It could be for software deployed on a device, an operating system, or other applications that come with your phone or other IoT type device. Could be deployed on the cloud as an application or some kind of background service, platform service, something like that. And it's important to know that the recipient, the customer for that SBOM can be anywhere in the supply chain. So, if it's a device like a phone, there's some original software that may come with the hardware that goes with that, then it's modified throughout the supply chain by various players or participants in the supply chain, and each of them essentially needs an SBOM for what they convey to the next partner in the supply chain. So the simple point is anyone who distributes software in any way will ultimately need to produce one or more SBOMs, depending on how many different roles they play in the supply chain. In the world today, an SBOM has become the prerequisite for managing license and vulnerability risks from third-party software. It's not a single standard, but it's the way to share information. And there's no way around automation. The volume of FOSS packages used in typical quote-unquote modern products is in the hundreds or thousands. There's just no way to do this by hand. So I mentioned earlier that there's a problem in identifying what the software units are, but there are some ways we can attack that, and the key here is to start working on it rather than sitting and waiting for some ultimate solution that handles it completely. Another key point about SBOMs is it's essentially now a requirement for doing business with government agencies. The exact requirements and the exact staging of those requirements is scattered across a bunch of government websites and that sort of thing. But it has become a standard, and it is going to be required again for business with the U.S. government in the next few years. There's a parallel effort in Europe, which is going to have similar requirements, and those two areas are leading the charge. So an interesting question to pose is, why haven't we used SBOMs before? Again, the model of discrete manufacturing is very clear. It would have been very useful to start before, but we are where we are, and we have to move forward. There are two emerging standards. Again, you've probably heard this many times. There's actually three that are mentioned by the government, but there's one called SWID, software ID, which is typically been used only by proprietary software and seems much weaker candidate. The main candidates are Cyclone DX, which came from OWASP and has a security focus, and SPDX from the Linux Foundation, which has a licensing focus. We do not expect a single standard. Hopefully there'll only be two, maybe three. And it is really important to remember that these are standards for the exchange of data between systems or between organizations. They are not design standards to how you build your own system. So the direct analogy to manufacturing is for EDI, which is the foundation of pretty much all retail commerce these days, partly thanks to Walmart. And EDI is a very specific standard for all sorts of transactions between companies. You don't build an internal system, an ERP system like Oracle or SAP based on EDI. You build those systems to be able to understand the data that's incoming or data outgoing according to those standards. So again, an SBOM is a standard for data exchange. There's a logical design you would have inside your systems, but it's not the same as the exchange standards. Another key standard I mentioned before is what is a piece of software, and our contribution has been defining something called a package URL. The key thing about a package URL is it allows you to identify a unit of software by its external characteristics. In other words, no one has to assign it a number. or put it on some kind of registry. If you can figure out where the software comes from, you can create a package URL, and there are the package URL project has software for all the major ecosystems to easily generate a Perl for your software. There really isn't an option to just wait for something that's final. You need to get started and start working with it. This will evolve over the years. It will require ongoing investment, but you need to get started and do the best you can in the near term, rather than waiting for some theoretically final specification that's a single standard. So what do SBOMs have to do with software supply chain security? Basically, this again comes back to manufacturing best practices. In a manufacturing supply chain, you're responsible for the quality of materials or products that you provide, and you're dependent on the quality of the products or materials you receive to include in your product. So there's a long history of this, but essentially organizations have figured out ways to track the origin and quality of materials, establish the level of trust that they have in the upstream provider, to determine how much diligence they need to do when, in this case, something shows up on the loading dock. But basically, when you accept, in our scenario here, if you accept software from someone else and incorporate in your product, you're ultimately responsible for whatever you then pass downstream in the supply chain. So you really have to understand both what is coming into your organization in terms of software, each element or each unit of software, and you have to share with your customer what you know about it and what you essentially are attesting to. So in the government case, you're being required to attest that the information you provide about an SBOM is accurate, and penalties ensue if you are not accurate. So again, looking back to manufacturing, we're going to have multiple standards. We're going to have multiple ways of doing things. In manufacturing, people have understood that for many years, and they just, get used to and skilled at translating the data. Again, we don't want dozens of standards, but you're going to have more than one. So you have to get used to the idea that the data will not always be completely standardized, and part of the job for organizing it is in your own organization. So a lot about SBOMs there, but that's kind of the deliverable, the tangible thing people are looking at. Software composition analysis are the processes and tools that allow you to create an SBOM, but they're actually much deeper and have been around longer than our current focus on SBOMs. We look at this in series of layers and talked about quite a bit here. The first thing is you have to identify what the software is. If you aren't talking about the same unit of software, then you're not talking about the same thing, and the rest of the discussion is probably suboptimal at best. And then in parallel, below identification, you need to know the licensing, because there's risks associated with the licenses. Most open source software is under permissive licenses, as it has minimal requirements, but you need to know that affirmatively. If a unit of software does not have a license, then you're not licensed to use it. There is no sort of default. You can use it if nobody said anything else. And security, which is a completely different dimension or different domain, equal at least in importance to licensing, and these two have to go side by side. And then another dimension that's very important, not something nexB is working on as much right now, but is overall quality. So once I know what this unit of software is, what can I find out about how much, what are the resources behind it, how often, or how quickly are bugs fixed, how many bugs are out there, what's the team's philosophy toward addressing security vulnerabilities, and so on. Again, here, all these cases, we're talking about public information for free and open source software. The same considerations apply for proprietary software, but the disadvantage is the information is not public. So we believe that software composition analysis has to be a core competency. There's really no way around it in modern software. Nobody in their right mind is writing every software program they use from scratch. Might be an interesting lab exercise or college class exercise. It's just impossible. As as it would be in manufacturing. Nobody's going to build a computer from scratch and, source their own silicon. Everything is involved in supply chain. So you need to pick tools, and which tools you use have a lot of considerations, and one of them, or a major area, is sort of what's your stack. What's your underlying platform, your open, either operating systems or cloud platforms. What types of technology do you use, back end, middle layer, front end, and particularly what your product does and who the customers are for it. Historically, we've seen more focus on the security side, security vulnerability side for SCA tools, because of the higher risk and the higher visibility of that risk through all sorts of media and industry channels. On the licensing side, there are occasionally major issues that surface for open source license issues, but often these are settled out of court or somehow hidden behind a legal screen, so you don't really find out about them in the same way. That's probably one of the factors. One of the challenges we see is that most of the tools focus on one or the other. So it seems a little bit like oil and water, which kind of makes sense because they're very different communities. Security engineers, application security people it's a very technical discipline, and it goes well beyond SCA. So what we're talking about here for software vulnerabilities is only part of the cybersecurity profile you need to have. There's all sorts of other tools like penetration testing and such that are also needed. They're not part of SCA. And of course, licenses, the experts are lawyers and typically not highly technical people. So it's not surprising the groups are not talking to each other much, but you have to deal with both. And you also have to think about the time dimension. So for licenses, the information may be very complex and may get very much involved in technical details like how you build a product. But once you figure out the license data for a major open source project, it's unlikely to change over time. They do change, but it's relatively low percentage. Vulnerability data is the complete opposite. It's extremely dynamic. So if you look at vulnerabilities for a set of 1,000 packages today, there'll be certain known vulnerabilities, there'll be certain known fixes. You can work from that data, but if you run that report another week, it may be completely different. You may have applied a fix, a new package version to fix a vulnerability, and then someone may have discovered a vulnerability in the package that fixed the previous vulnerability. So you just have to look at these in a completely different time frame. But what ties it all together is, what are these software units? And ultimately, you need to cover both bases. So it doesn't really help you if you, have complete license compliance and have ignored security vulnerabilities or software vulnerabilities, and vice versa. And the quality piece is also very important. It is one of the reasons we're not nexB is working on that so much, is that there are other projects like Chaos and so on that are handling that in many ways. So we plan to work with them rather than reinvent the wheel. Again, referring to other FOSS tools that are in the market. So a particular trend we've seen since the rise of SBOMS is lots of proprietary companies, a lot of VC startups getting in the space. The general trend is to try and charge you based on the total number of developers, which can become daunting if you're a big organization or small organization. Theory is that everybody benefits from this, which is probably true, but this is not sustainable for people actually getting the work done. You can't spend this much money on proprietary licenses or subscriptions and still have the resources, the money left to get your own expertise and your own people. In the short term, those will work for large companies, but the other key point is they're not going to work for the community at all. If you're an upstream project, even if you're funded, you have resources from a major corporation, whenever you don't have the budget, you can't sign up for $1,000 a developer for everyone working on your project. And if it's a community, you can't even define who those developers are. They're not your employees, they're contributors. And how would you work that out? So it's just a dead-end solution for real supply chain security to use proprietary solutions, except perhaps in the largest companies that have the most money to spend. So, well, how do we approach this? For nexB, from the beginning, we said we're going to build modular tools, not trying to force anybody into a single solution or single platform. And our basic approach is that the software is licensed under Apache 2.0, and the data is licensed by Creative Commons share alike. Eating our own cooking, we use lots of other open source in our projects. We are careful about making sure those licenses are compliant, but obviously software from other groups that we leverage inside our products may not be under these licenses. This is the licensing for the nexB produced products. And here's a list of the major products. ScanCode is a set of tools. There's several of them. It's a code scanning tool, identifies software and the licensing. VulnerableCode is a relatively newer tool. There's actually also a public database. And what we do here is once we have a package identified by ScanCode, we can show you the vulnerability information, including fixes from across the FOSS world. CVEs are covered, of course, but lots of other data sources. And the newest is a product or a project called PearlDB, which goes back to the package URL. And this is a database of package metadata across the supply chain. We're not making copies of the software itself, but we're uploading and maintaining a database of the metadata, the licensing, the origin, all sorts of interesting information. And tying it all together is DejaCode, which is a management application. DejaCode is not currently an open source tool. It's a business application from subscription. We have a very simple and reasonable pricing strategy for that. We'll talk about that. It leverages these other tools, but you're not required to have DejaCode to use any of the other tools. It's all independent. So this is a diagram showing you some of the major elements. So up at the top, DejaCode is dealing with policies, licenses, components, packages, vulnerabilities. It's intended to work across all your teams. So it's an enterprise level application where you have many different products with their bills of material. It has an internal representation and can consume an SBOM from someone else, can generate SBOMs. But this is again, a business-oriented application. Everything is covered with APIs, but there's also screens where a legal department can go in and apply policies from licenses or components and so on, and those can all filter down in the system. So DejaCode is again very much a GUI application with full API access to everything you can do in the GUI. At the bluish layer below, that's a set of tools we generally call AboutCode, but ScanCode.io is at the center. We'll talk about what they are a bit later, but the idea here is that these are all independent modular tools. In DejaCode, we've tied them all together, so they're essentially, you can call them pre-integrated, but you can also use the various tools individually. On the database level at the bottom, the one I haven't talked about before is the license database. This is, again, a public database of all the licenses that ScanCode can detect. Most of these are open source, but some of them are what we call proprietary free. In other words, public licenses that are closed source, but give you some of the privileges of open source. So we'll talk more about these details. ScanCode can also consume an SBOM or produce an SBOM at a different level of detail than say DejaCode. But this is sort of the big picture of our tool set. So again, DejaCode is a business application, and it's intended to bring this information together across all your products. When you work at a product team level, you could have product teams with very different technology stacks. They may need different sorts of solutions in the details of how they manage their code. They may, in fact, even use a different source control system, a different build system, and so on. So at the tools level, you want flexibility to adapt that to a subset of your organization that may do things differently than another group. DejaCode brings this all together, and it's exactly the same functionality whether you sign up for software as a service with us hosting this solution or install it on premises. ScanCode is the premier solution for actually identifying free open source FOSS components and other third-party components. The key areas are licenses, copyrights, and dependencies. There's lots of other data, but that's the focus, and we have specific techniques for each. For licenses, we have a matching model against our license DB that's very sophisticated. Key point is that you can update or add licenses all with data. There's no code required to add a license to the detection system. Copyrights use a variety of regex types analysis, and dependencies can understand all the different types of package manifests that exist in various ecosystems and provide that data. The main product is called ScanCode.io. It's essentially a server. Most people run it with Docker. It has pipelines for different types of analysis, which normally are going to have a ScanCode toolkit scan in there. So ScanCode toolkit's the engine here. But with ScanCode.io, you can add steps before and after the scanning, quite a bit of sophistication there. Some other products, the license DB I've mentioned, there's also a desktop app for reviewing scans. ScanCode Analyzer is a sort of an it's public, but it's a tool to sort of improve the scanning itself. So it's kind of a inner cycle, and there are others. But so ScanCode is a product family, but the main ones are ScanCode.io and ScanCode Toolkit. VulnerableCode pulls data from upstream projects, from GitHub, Linux distros, the National Vulnerability Database, all sorts of sources, constantly adding sources. A big part of the work here is applying analysis and confidence to the data. So we discover lots of inconsistencies. You may get a vulnerability reported for a package that doesn't actually exist, a version of software that has never existed, generated from some tool. Lots of false positives and strange data. So by comparing data about related vulnerabilities, we can find those inconsistencies and help avoid wasting time on false positives. We have a public version of this database. There are some limits. It's not a solution for super high volume queries, but you can access through the API. We also have all the code if you want to build your own database and collect your own data. But we're committed to keeping the primary database, the reference database, available publicly. And for example, this would be very useful for open source projects because the API would certainly allow the use at the level of API calls. It would be typical of an open source project versus a very, very large company. And the Perl DB is quite new. This is basically pulling data from package managers as an initial focus, but also source repositories, Linux distros, and eventually C and C++ and other projects that don't have the packaging mechanisms or infrastructure that modern packages do. Part of the goal for this is to allow you to do package or file matching in addition to scanning. So if you get a binary that's been stripped of all symbols, you may have a name to work with. The name may not actually tell you much. So one of the techniques here is to use SHA-1 matching or other types of tracing of technical symbols inside a binary, that sort of thing, so that you can figure out what this is and what its license and security profile is, even though the scanning tool is blocked because the file or the package does not have the metadata anymore. It was stripped out in the process. As with VulnerableCode, you will be able to build your own Perl DB, and we will offer a public version in the near future, again with some limits on the volume of API access, but one that should be well suited to open source projects and their needs. Lots of other projects. You'll see a bunch here at the top called inspectors. So an inspector in nexB lingo is a deeper dive tool into a particular ecosystem. They're not all exactly the same. For instance, containers are not the same as nuggets or Python packages. But the idea here is that it's this code that's very vertical. It's customized to the specific type of software unit that you're analyzing. a Debian package or a container or a NuGet package or a Python package. This is the set that's available today publicly. We are working on more and looking for sponsors to help us develop more of these. Basically, we ultimately expect to have an inspector for every major package ecosystem. And then some other projects. There's actually our oldest project is called AboutCode Toolkit, and it's a specific set of tools that allow you to generate attribution notices quite easily in many formats once you have an SBOM. Package URL we talked about a bit. Again, this has become the standard for identifying packages. CycloneDX, ORT, other projects have adopted it. The National Vulnerability Database is considering adopting it not as a replacement for a CVE, a CPE, Common Platform Enumeration, but as an alternative to a CPE. Not exactly sure where that is. We are not, we don't have a role with the government, and that other groups are working with that, but it looks like that's going to happen. And following on Perl, we have a newer project called Universal Version Matching, and this is intended to deal with the complexity of package versions, which are dependencies are often expressed as a range or a greater than or less than, and so on. So this is a set of general tools to deal with that problem. And there's a lot more. So you can find us on GitHub, and all of our projects are listed there. Some are big, like the ones we discussed. Some are smaller. There's all sorts of other tools we've contributed to the community. So that's our quick run through. I'm Michael Herzog. You can reach me at the email. Philippe is the co-founder and CTO of nexB, and Dennis is the product manager for DejaCode and overall tools. There's information at nexb.com. There's also information on GitHub. We appreciate your interest in FOSS for FOSS to help secure the software supply chain, and be happy to talk to you in future about any of your specific interests or needs.